Right. Good afternoon, everyone. Is everybody having a great conference? Awesome, awesome. Thank you so much for your time. I know that there are lots of very good sessions happening at all times, and I really appreciate and thank you for taking time and being in this session. My name is Krishna Mamidipaka. I'm a Principal Program Manager on the Azure Big Data team, and my specific area of focus happens to be, of course, streaming analytics. And over the course of next 75 minutes, I will be joined with one of our esteemed customers, Ms. Chetna Gupta from Evolve Guest Controls, and both of us together are going to bring you this session. Before we go into the agenda, can we do a quick show of hands? How many of you have used Stream Analytics? About 35–40% of the room. And how many of you are working in companies or teams that use Stream Analytics? Maybe you have not personally used it, but your company uses it. All right, so we have a mixed bag, and I'm hoping that this session has something for everyone in it. So just a quick run through the agenda. I'm going to talk a little bit about what is streaming analytics, what are some of the key scenarios. I will present a few customer stories, and then I'm going to invite Ms. Gupta to come and talk about their implementation of streaming analytics. And then we have some very exciting announcements that we want to make today for the first time in this occasion, at this event. So I'm going to spend a good amount of time talking about some of the new features that we are announcing today. And finally, I'm hoping that we have a good amount of time left for me to show most of these new features in action, assuming the demo environment cooperates. There is always uncertainty around that. And we will have time for Q&A. So I just want to have one request for you. Let's hold off on any questions till the very end, because we have a very aspirational long agenda to go through. And we promise me and other members of my team are going to be here or outside this room until we address each and every question. Is that all right? OK, great. So let's talk about what is real-time analytics, what is streaming analytics. Streaming analytics is all about analyzing the data in real time while the data is still sort of on the wire. When we think about a traditional analytics scenario, what is happening? You are bringing the data, you are putting it on a database, and then you are analyzing that data. You are bringing the query to the data to give you whatever insights that you are looking for. But in streaming analytics, we kind of reverse this whole sequence. Rather than taking query to the data, you are bringing data to the query. Let it sink in a little bit. You're not bringing query to the data, but rather you are bringing data to the query. The queries are always standing on the wire, so to say. And as the data is pulling through the wire, we are analyzing the data for whatever scenarios that you are probably interested in. Let's think about a few scenarios. Everybody have used credit cards. We go to a point-of-sale terminal. We swipe our credit cards. And what is happening in this time? The credit card gateway company has to do multiple checks. It has to check if you have enough balance left. It has to do some machine learning algorithms to understand if it could be a fraudulent transaction. All of this, you need to get the response back within 1 or 2 seconds. Do you think there is time for this credit card company to go, situate your event on a database, run machine learning algorithms on it, check if there is enough balance left, and then give you the result back? Probably not. So these are the kind of scenarios where streaming analytics is of big use. Also, think of scenarios like fraud detection that I just talked about, IoT scenarios. Let's say you have a machinery on the shop floor, and you want to detect some catastrophic event happening with the machinery. Maybe it is vibrating more than it should, or maybe it is overheating more than it should, and you want to go and shut it down or slow it down within a second or two of having detected this, right? So chances are you probably use stream analytics for scenarios like this. And the extent of use cases go across the board, and I'm going to talk many scenarios like that as we kind of go through this session. Let's talk about what is stream analytics and what differentiates stream analytics from other services out there. First and foremost, it is all about the ease of getting started. So 2.5 years ago, when we were still sort of designing streaming analytics, we had a decision to make. Should we use imperative code like other open source and proprietary services were doing for streaming analytics, or should we take a big, bold bet and provide a SQL language head, more of a declarative language for users to interact with streaming analytics? We were among the very first, if not the first, to make this bold bet, and the results have been spectacular. Now, if we turn back and look at what other competitors, both in the open source and proprietary space, are doing, they are all trying to emulate their success that we've had with this particular approach. Second one is all about developer productivity. So we understand that there is a lot of emphasis on getting solutions fast, getting to the market quickly. And so streaming analytics, we have invested quite a bit of time and effort to make sure that you can build end-to-end streaming analytics pipelines within a few minutes and be operational. So what does that really mean? We integrate with 12 to 15 services in Azure, both upstream and downstream, to streaming analytics with just a few simple clicks. You don't ever need to write even a single line of code in order to do that. Next one is all about not just operating in the cloud, but today we are available also on the IoT Edge runtime. If you have those scenarios where you cannot wait even for those 2 or 3 seconds for you to be able to send data to the cloud and analyze the streaming data, you can bring down your query from the cloud to the IoT Edge runtime so that you can get sub-second and millisecond-like latencies. It is a PaaS service. It is a fully managed PaaS service on Azure. There is no clusters for you to manage. There is no hardware for you to provision. You can get started literally within a matter of a few seconds. And we also offer a very attractive price point to get started. And we provide 3 nines of SLA, right? And it is not just about providing 3 nines of SLA, but we actually financially guarantee it. We financially back it. If at any point of time you see that this 3 nines of SLA is not guaranteed or you're not able to achieve it, we actually refund the money back. And this SLA is calculated at a minute-by-minute granularity. There is no other vendor in the market that actually does and stand behind the SLAs like we do. How many of you have ever written SQL queries? Congratulations and welcome to the ASA family. You're all ASA developers too. And as you can see here, most of the queries that you use within streaming analytics are what you are probably used to in the SQL domain: select, where, group by, sort, right? And we actually use the same SQL compiler as Microsoft SQL Server, and we extended it in order to enable temporal and time functions, right? And we provide out-of-the-box functions for geospatial analytics. We provide various different types of windows, whether it is sliding window, hopping window, et cetera. And there is a lot of very good documentation available on Azure.com if you want to quickly learn about all of these functions that are available and get started. Less code equals much more developer productivity. About 2 years ago, there was a lab experiment that we did back in Redmond, where we took a very simple scenario, tried to do it in stream analytics, and then tried to replicate the same in an open source solution. And as you can see, something that just took 3 lines of code in stream analytics took about 2,000 lines of code in an open source solution, which was Apache Storm at that time. And even the other open source solutions are probably like this even today. We make it super easy to assemble real-time analytics pipeline, and here is a canonical architecture. Let me take some time and talk to you about what is happening here. On the very left-hand side of the screen, you have data coming in from your applications and sensors. It could be an IoT sensor, or it could be a Twitter application, anything that you're constantly wanting to monitor those events. And we require that you push the events into Event Hubs or IoT Hub, from where we continuously pull the data. You don't have to push it into stream analytics. We constantly scan these event sources for newer data coming in, and we pull the data from there. And we analyze the data. We also have the ability to join these fast-moving streams of data with what we call um, you can join fast-moving streams of data with reference data, right, in order to light up many more scenarios. And I will dig a little bit deeper into that. And as the data is being processed in Stream Analytics, you can also do real-time scoring on the data. We let you integrate with Azure Machine Learning Studio. You can bring your pre-trained models, and you can score these events in real time. And once the data is processed, you can do various different things with the data. You can store it in SQL DB, SQL Data Warehouse, Cosmos DB. The list goes on and on and on. You can also power real-time dashboards. We actually support streaming data APIs, which we worked very closely with the Power BI team in order to provide that dynamic dashboarding real-time experience there. And many of the customers, they want to do many of these things, including triggering some actions and workflows downstream. Let's say you're monitoring your IT infrastructure, and suddenly you see that you are up to 90–95% of your memory capacity in your data center. You can automatically trigger a ServiceNow ticket so that it gets routed to the right technician within a matter of a few seconds of that event happening. Stream Analytics is available in 26 regions worldwide, and we do realize that especially for a service like Stream Analytics, it is very essential that you have your data center closer to the data where it is being generated. So we are making a lot of investments to make sure Stream Analytics is available in as many Azure data regions as possible. And please do follow @Azure Streaming, our Twitter handle, because we make lots of interesting announcements like this as and when they happen on that Twitter handle. We spend a lot of time trying to ensure that we comply with all the latest and greatest security, privacy guidelines that are thrusted upon us through industry and federal regulations. And the result of that is that we are a highly certified, highly compliant service. And that should give you a lot of confidence to do business with Microsoft and in turn do the business with your customers that you might serve. ASA, Stream Analytics, provides proven performance and scale. So Stream Analytics might be 2–2.5 years old, but it is based on what we call Trill. It is a Microsoft research offering. It is now available as a non-commercial license as well, and that has been around for about a decade and a half. And Trill, like the name suggests, stands for being able to analyze trillions of data events per day on a single core. And those are the kind of artifacts, research artifacts that actually power Azure Stream Analytics. And we continuously derive a lot of benefit from other parts of Microsoft, like ML, like Trill, the Microsoft research offerings, so that we continuously deliver more and more for our customers. And we also power some of the most demanding internal pipelines in Microsoft. We power the Bing Ads pipeline, which is worth billions of dollars a month. And also the Office 365 telemetry pipeline, which requires us to maintain state worth a few terabytes on a daily basis. So the result of all of this investments that we are making to support this internal workloads are something that over time get translated to the benefits that our customers can actually enjoy. Here is a sampling of key features that we have announced over the past 18 months or so. And it is just a sample of the user, the features that users can experience. But we have the ability right now to push features almost on a daily basis. You might not see all these features because there are a lot of features that we invest in that tighten the security, that makes privacy even more tighter, and the performance. So we keep making lots of changes to the backend service, but what you see are more user-centric features that we have defined and released over the past 18 months. And this does not include a pretty long list of features that we have for you that we are announcing today. We provide Stream Analytics at a very compelling price point. You can get started at just 11 cents an hour in US pricing. Of course, the price differs from region to region based on foreign exchange and the cost of doing business and whatnot. But for the smallest footprint of compute and memory, we charge you just 11 cents per hour, and it is the lowest in the industry. In the last 2 years, we've been very successful gaining thousands of customers. So what you see on the screen there, it is just a sample of about 45 or 50 publicly documented case studies that is available for you to look at azure.com/case studies. And I'm going to talk about some of these right now. NASCAR. NASCAR is a customer of ours. And you know NASCAR is synonymous with speed. NASCAR came to us with a challenge. Their challenge was to reduce the restart time in the races during the race day when collisions happen on the race course. So what we did is we worked very closely with them to evolve our geospatial analytics so that we can determine the exact location of every car on the racetrack so that they can minimize the race restart time after collisions happen. They are also using Stream Analytics to detect any kind of speeding that happens in the pit lanes and penalize the drivers accordingly. SkyAlert. It is one of my favorite case studies. They're a customer based in Mexico, and their unique selling point is that they can alert people in a region where there is abnormal seismic activity almost 40 seconds before the government alert systems get triggered. As you know, during the case of calamities like earthquakes, every second is of utmost importance. And what they do is they have sensors all across the coast of western Mexico, and as and when they detect abnormal seismic activity, they send alerts to all their subscribers, both individual and companies, asking them to take cover. And one of the biggest asks for them was to have a service that is highly available, because there is no point if they are using a service that doesn't have the kind of SLA guarantees that Stream Analytics provides. So today, Stream Analytics provides 3 nines financially backed SLA, which roughly translates to about 35-40 minutes of downtime in any given month. I'm saying this because we are actually striving to get to a 4-9 SLA very soon. Any guesses? Between 3 nines and 4 nines, how much is the difference in terms of the tolerable monthly downtime? 4 nines SLA translates to 4 to 5 minutes of downtime every month. And that is going to be financially backed, and that is what we are striving towards. Southern Company, they are a US company, power and utilities company that is more prevalent in this region, Georgia, Florida, Mississippi, et cetera. And they use Stream Analytics to track their expensive equipment and crews, especially during the time of bad weather. They have these crews that are out and about fixing the down power lines, and they want to ensure that these crews are always trackable, and they know exactly where every crew member is, and the expensive equipment that they are driving is also at. And they use geospatial analytics to determine if a particular expensive piece of equipment is off the grid, or they also use Stream Analytics to determine unsafe driving practices of their drivers, if they are speeding, if they are accelerating, if they are braking very fast, right? And right now they are in the process of fitting their transmission networks with sensors so that they can know of any outages before the customers even call them back. Some other notable features, we work very hard on providing as much temporal semantics as possible that you can define in your logic without writing any piece of code. For example, you can determine if you want to process these events based on the time at which the event got generated in the application or the sensor, or you can opt to process these events based on the time that these events land in the IoT hub or event hub. You can very easily, with very simple configuration settings, manage out-of-order events. You can set time policies, et cetera, which requires a lot of time and effort if you were using like an open source software. You can join, like I said, multiple streams of data or streams of data with more static reference data. Another thing that you can do very easily is you can set certain offsets in the processing of the data. If you want all the events that got generated at the same time to be processed at the same time in Stream Analytics, you can set certain offsets so that all your data streams from across the world, across your plants catch up before everything gets processed together. Or the other way around, if you do not really have any relationship between all these different events coming in within the same query, you can use certain keywords to process each event independent of the timeline. So we provide a lot of flexibility for you, for your scenarios, so that you can be very efficient without writing a whole bunch of code with just a few simple configuration parameters. We've been continuously investing in making stream analytics really favored for the developers. When we started, it was mainly through Azure Portal, but over time, as you can see, you can interact, you can deploy, you can author stream analytics using PowerShell, .NET SDK, REST APIs, and Visual Studio as well. And with the Visual Studio, you also have the ability now to do to set up your CI/CD pipelines. We provide a long list of features to help you monitor these hot path pipelines, right? We understand that we need to provide as much insight for you to understand what is happening under the hood. And job metrics diagram is one such feature, right? No matter how complex your query is, we will let you understand the structure of this query through a very simple logical view of the query. You can simply hover over these individual parts of the query, and we will show you all the metrics associated with it, like how much data is flowing into it, how much data is flowing out of it. It is not just a very good monitoring tool, but it is also a very good debugging tool. In the first run, the developers can see if there is any part of the query that is behaving abnormally, it is not processing any data, and so on. Reference data joins, like I mentioned, you can join fast-moving streams of data with reference data. Why do you want to do that? Because you want to conserve your bandwidth, you want to prevent congestion in the network traffic. There are, for example, let's say you have a sensor data stream coming in, and for the dashboard that you have, you also want to show who is the manufacturer of that sensor, when was it last serviced, and these are the things that don't change very often. So those are the kind of data that you can put in a reference database, and at the last minute, you can join the stream of data with reference data so that you have a very contextual, very nice dashboarding experience. Same thing, think about high-frequency trading scenarios. You are joining the option streams coming from the stock market with the historical volume, historical pricing information related to that stock or that option so that you have a very nice recommendation engine for sell-by recommendations. Geospatial functions are provided out of the box in Stream Analytics. The whole world of connected cars and fleet management is just heating up like crazy, and we want to make sure we are in front of the game here, trying to provide very strong geospatial functions that are built and baked into Stream Analytics. You can do interesting things like define geofences, measure distance between different points, determine if a particular point is within a geofence, outside of it, and do very interesting scenarios. We are working with a telecom company based in Australia where they want to track with little devices if a particular pet that is being tracked is beyond 50 meters of a particular zone, particular school, and things like that. Stream Analytics is available on Azure IoT Edge as a first-class citizen. This is in public preview right now. The only thing that is holding us back from putting it in GA is the price meter, and we are probably going to put the pricing meter. So if you use streaming analytics on Azure IoT Edge today, it is almost like GA-like capabilities, and you can use it for free. So definitely take it for a spin there. And why is Stream Analytics on Azure IoT Edge so popular? First of all, it is all about ultra-low latency command and control scenarios. Scenarios where you do not have time to send an event to the cloud, right? You can simply bring your ASA query onto the edge device so that all the processing is happening on IoT Edge runtime. It is also very useful for scenarios where there is limited connectivity to the cloud or bandwidth is very expensive. We have customers in the Nordic regions where they have these wind farms in the middle of the ocean. And they want to know if a particular turbine has excessive vibration, if it is heating up beyond a particular tolerance level. So what they do, and these wind farms are connected to internet to their data center through satellite connectivity, which could be iffy, or it could also be very expensive. So they actually bring the Stream Analytics queries from the cloud onto the device so that there is local command and control operations that is completely controlled by the cloud, but that is not happening in the cloud. Compliance. A lot of customers tell us that their compliance dictates that they cannot move the data as it is into the cloud. So you can anonymize the data, or you can do the necessary filtering before you actually send the data into the cloud for machine learning training and scoring purposes. A lot of advantages of using streaming analytics on Azure IoT Edge. The first and foremost is it is the exact same language that you write in the cloud that is also applicable for the edge. In fact, we are one of the one or two vendors out there which lets you use the same language in both the cloud and on the edge. The second big reason is we are a cross-platform. We are a truly cross-platform. We support both Windows and Docker containers running on both Intel and ARM architectures. And we leverage all the richness and investment that is going into the Azure IoT Edge runtime to help you secure the devices, secure the processing environment, and very easily, with a simple click, you can update the query to thousands of devices if you want. All right, so over to some very exciting announcements that we are making for the first time at this event this week. And some of these features are in private preview, so I leave a URL on the screen there. If you are interested, you can sign up for these features, these private preview features right now. The first feature is extensibility with C#. SQL got us to the point where we are right now. And for a set of customers who want to do some very deep mathematical calculations, imputation logic, etc., we want to make sure that we are providing them with all the tool set. So with C# UDF, you can extend the SQL language that you use today. And we are announcing this feature, C# extensibility, for the first time on Azure IoT Edge. So this is a scenario where actually Edge is ahead of the cloud. We will provide this capability also in the cloud. Just give us a couple of more quarters or so. Next feature, also currently applicable for Azure IoT Edge. As you can see, there is a lot of investment that is going into the Azure IoT Edge. This is all about custom deserializers. This is one of the biggest features that we've been asked and requested by the Azure IoT community for a very long time. Today, Stream Analytics, until today, Stream Analytics supported JSON, CSV, Avro formats. But going forward, you can bring any binary format or protobuf, Parquet, XML, and you should be able to build your custom deserializers through C# extensibility, and we will be able to process no matter what the data format is. This is currently available, once again, on IoT Edge, and we will fast follow this with announcement in the cloud. Custom output partitioning to blob storage. So you can now partition your egress to blob storage based on custom date-time formats, or also through certain attributes of your incoming data or a custom field that you have defined in your query. So this is really useful, especially in scenarios where you want to have more contextual dashboards, where you want to have a multi-tenancy dashboarding experience, and especially if you're an ISV, you want to have different dashboards for different customers. So you can actually partition your egress to Azure Blob Storage, where Power BI is picking up from, in a very easy way. And the custom partitioning by date and time formats is very useful in Hive-supported formats for downstream processing. If you're writing data to Azure Blob Storage or Azure Data Lake, and you want that data to be processed by Azure Databricks or Azure HD Insight, this partitioning scheme is going to make your life that easier. Local live data testing in Visual Studio. So you can now use live data coming from your IoT Hub or Event Hubs and do live data testing in Visual Studio. You don't have to collect a sample of the data, upload it, and then test the data and test your query. Even if the query otherwise in the cloud is running, you can still test the same query. So that will make the developer's life really productive. Built-in ML models for anomaly detection. So this has been a feature that has been in private preview for a few months. And we are continuously learning from our early adopters, and we are making a lot of changes to this. In our last release in private preview, we had about 5 different functions to find 5 different anomalies, spike, dip, bi-level changes, slow positive growth, slow negative declines, and things like that. But now we were able to bring down 5 different functions to just 2. So let me just talk about what is the advantage. Data scientists do not come cheap. They are very expensive. So what we did is we worked with Microsoft Research and got their algorithms for anomaly detection and just baked into the code base of Stream Analytics. So what does this mean? It means that for anomaly detection scenarios, you don't have to build and train your models and do scoring. You can with a simple function call, you can just activate anomaly detection within Stream Analytics. And it is both inline scoring and inline learning at the same time. It is a pre-trained model, but we also learn from your data before we actually score the data. And there is going to be a simultaneous announcement that is going to be made by the ML.NET team where they are going to be supporting these models. Right? These are the models that will be also available in ML.NET very soon. So very simple function signatures. Like you can see, for change point and spike and dip detection, all you need to provide is your parameter, which is the temperature, humidity, or any other parameter that you're measuring, and provide a confidence interval and the number of data points the algorithm needs to learn from before it starts scoring. It is as simple as that. The whole complexity of machine learning model training and scoring has been abstracted out to a very simple function call. High throughput output to SQL. Today we support a single writer when you write data to SQL DB, but we are going to change that to a parallel write operation. So we have a lot of customers who actually output to SQL Data Warehouse or SQL DB, and this is going to be a feature that is going to be super useful for them. We are not done yet. There are 2 more features that I want to talk about. MSI-based authentication while you write to Azure Data Lake General. Today, we support Azure Active Directory-based authentication, and it has a few drawbacks. The first one is that you cannot have a long-running job because every so often you will be prompted to add your password or to change your password. And also, you cannot operationalize and automate the deployment of jobs programmatically or systematically. So with the MSI-based authentication enabled for the egress to Azure Data Lake, you can do all such scenarios very easily. Finally, user-specified custom repartition count, right? So you can specify the number of partitions that you want on the egress side for Azure Stream Analytics now. And it is a user-defined parameter that you can specify, really useful for scenarios where you cannot change the partition key upstream, or when there are a fixed number of partitions for output. For example, for SQL DB, if you know that 4 or 6 partitions are going to be the most effective, then you can simply set this repartition count to 4 or 6 while writing to SQL DB so that your write performance to SQL is going to be very efficient. At this point, I will invite Chetna to come and talk about their use at Evolve Controls of Stream Analytics. Chetna.
Good afternoon, everyone. I'm Chetna Gupta, and I lead the technology for Evolve Controls. I want to begin with thanking Microsoft for giving me a chance to talk at Ignite for our usage of Stream Analytics in our solution. Evolve is a provider of room automation, controls, and management solutions for hotel industry. We provide our customers with trifecta of benefits: guest experience, operation savings, and energy conservation. Guest experience, we all have stayed in hotels. It's really important that the first impressions and the guest stay is very convenient. So we provide our customers with tools that they can impress the guests throughout their stay. For example, we have the ability to execute welcome scenes when the guest first arrives into the room to give them a moment that they feel excited about being into the room. Operational savings. Hotel staff utilizes Evolve's Insight dashboard to gain visibility into what is happening in the room. If there are any issues, they have the opportunity to fix the issue even before the guest finds out that there is a problem. Energy conservation. Evolve has the ability to automatically apply or make changes to the room based on the occupancy status of the room. So hotels and operators have an ability to change the set points when the room is not occupied or is not rented. There's no point heating or cooling the room when there is nobody in the room. So our backend is able to achieve all these benefits by using a lot of Microsoft products. We are a Microsoft shop. We use Azure as a platform, use IoT Hub, cloud services, SQL databases, Stream Analytics, Cosmos DB, a lot of things. But since we are in the session, I'm going to focus on Stream Analytics. So the use cases that we use Stream Analytics for can be divided into 3 categories. Hotel staff is able to gain the proof of life component by looking at the system that provides an insight into their rooms. So they can know that the room is healthy. They can get a real-time analytics on what is happening on the room, like room status, occupancy, Wi-Fi status, status of devices, is the room connected? All those information is available on their fingertips. Hotel staff has a visibility into their operations with trending information, so they can predict if there is a problem and do preventative maintenance before the issue actually happens. So before, if the hotel AC wasn't working, a guest had to call into the front desk and tell them that the room is not heating or cooling properly. Now with all the data that we get from these devices, we are able to combine all these data points and figure out that the AC is not working optimally and can optimize their, and they can go back and fix the problem at the HVAC or the air conditioner. We also can combine the data points and create a matrix to determine the ROI and the energy consumed by the room. So all these parameters are very important because states like California require the regulation for them to calculate how much energy is being used by the rooms. So just to kind of give you an overview of our architecture at a very high level, we have a gateway that sits in the room, and all the devices are talking Z-Wave with a gateway. And as the gateway detects that there is a change in the data point, it sends out information to IoT Hub. Now, that information that goes to IoT Hub could be as simple as a change in the ambient temperature in the room because it was detected by the thermostat, or it could be a complex data point like a light switch is not working, something that our gateway has figured out by talking to the devices. And it's a very important data point for our hotel staff to know that the light switch is not working. So as the data arrive into the IoT Hub, it then gets shipped into 2 different Stream Analytics jobs. One is analyzing the data at real time and feeding our dashboards, and the other is really creating, sending data to storage accounts so we can have trending reports for later. So I've talked a lot about it, so I'm going to move on to the demo and show a couple of Stream Analytics jobs. And that is 6, I think. Okay? I'm going to show a couple of Stream Analytics jobs. One is really simple. As you can see, this only tells me if there's a change in the device status. The input to this job is IoT Hub. This is what we have all our data coming through. The setting up of input for IoT Hub was as simple as Krishna just mentioned. It was a few minutes. We just had to say an input, IoT Hub, put the configuration information, and we were done. The outputs, as you can see, there are 2 different outputs. One is going to blob storage, and one is going to databases. Again, really simple. And we have jobs that are going output to many different things. Then the next comes is we have a lot of data coming on the IoT Hub, but for this Stream Analytics job, I'm only interested in a couple of different kinds of events. So we use the where clause. Again, we are a SQL development house, so everyone knows how to write a where clause. So it was very easy to filter out the events that we wanted to look at. And then we want to see if the status of the device has changed from the last time we saw the event. So we use an operator called lag, which allows us to look up previous events in the event stream. And we can know if the status has changed or not. If it has changed, we push it next to the next output. If not, then we don't really care because the status of the device is the same. The second job that I want to show you is a little bit more computational sensitive. So the intent of this job is to identify the rooms where the ambient temperature is outside the acceptable range for more than an hour. That's something that's very important to the hotels to monitor the HVAC's effectiveness. So in order to do that, we used a function called hopping window from ASA that enables us to look back at events every hour, every 5 seconds. So the previous, in the lag, there has to be an event that comes in for us to look at what was happening. In this one, every 5 seconds, we are looking for events that has happened in an hour in order for us to find out if there is a problem with the HVAC. This is a kind of a sample of a dashboard of some of the jobs that we have that we keep monitoring, and it helps us figure out the health of the system. And then we've created alerts so that we could figure out if there's a problem in the whole solution working end to end. And the other thing that we use a lot is job diagrams, and I think Krishna kind of alluded to that. We look at very simple queries where you're looking at what's happening on the plan, but one of the very important things that we use internally is the troubleshooting aspect. So if in case there is a problem with the job and I want to replay the events that might have caused it, I have the ability to do it from the click of a button, and I go hit the replay button and run it through to figure out if there is a problem with the data stream that's coming in. So that's on the demo side. Yeah, let's see. Moves back. Okay. And these are the dashboards that are available to our clients. So one of them is showing the health of a hotel, and we have the ability to drill down to the room level. The other is the HVAC utilization. This one shows the issues that are there in the hotel by room and by the device level. And the third different kind is the trending of ambient temperature. And over time, that is being powered by Power BI. So why did we use Stream Analytics? There is no cluster. We're a small company, so we don't have an army of people. So there was no cluster or infrastructure that I had to manage. We are a Microsoft shop, so skills for SQL were very easy. So it was very easy to translate to Stream Analytics. We have streams of data coming from these devices, so the technology we chose had to be able to handle Stream Analytics or streaming data. Integration to IoT Hub was as easy as adding configurations. We have more and more hotels coming online, so scalability was very important to us. And then we could send data to multiple outputs, so that reduced the number of footprints or number of Stream Analytics jobs that we needed. So what next? Krishna had a couple of good new enhancements that they've added that we are really excited. We've used the ML in preview. We're going to be using that a lot for predictive analysis, and for reactive maintenance, we're going to be using those machine learning algorithms. And also the parallel write for the database operations is very important to us, because sometimes the number of events that we get in is so much that it throttles that output. So multiple parallel writes would be great help for us. So I think that's it I had. I'm going to pass it on to Krishna.
Thank you, Chetna.
Thanks.
A quick word about Evolve Controls and Chetna. They are one of our very special customers because we co-developed a lot of features working with them, and they were able to really pinpoint to many pain points previously over the course of many months that we have continuously tried to refine the product. So the amount of feedback that we collect from the customers like Evolve Controls and continuously improve the quality of the service is second to none in terms of the services that are available in Azure. So I definitely encourage you as well, when you are using Stream Analytics, to have very close contact with us. So some of the call to actions before I run into the demo, or please do sign up for the private preview features if you are interested at the URL there. And like I mentioned, we announced a lot of new features, a lot of interesting news, tips and tricks on our Twitter handle, which is at Azure Streaming. And engage with us, write to us. We try to respond back to any customer questions within 24 hours of getting them, whether it is on askasa@microsoft.com. It comes directly to the email boxes of all the program managers who work on the product. And we strive to provide a response back within 24 hours of getting the question, both on email as well as on MSDN and Discuss and the other forums. So at this point, I want to show some of these new features that we are announcing today in action. So these are coming in pretty hot, so don't mind if some of these demos are flaky or don't work, but it just means that it is real. All right, I had one more slide. So this is the demo architecture. So in our first set of demos, what I have happening is I have a sensor that is generating temperature and pressure data, and the sensor is working on IoT Edge device. And for simplicity purposes, I have deployed IoT Edge runtime on my laptop, and I'm generating data through this sensor on my machine. So in the first run, I will show you what is the kind of data that this sensor is sending into the cloud. Let's get a good handle on the data. Is it spiky? Is it constant? How it is? And then let's try to detect if there are any anomalies using the built-in machine learning functions that I just spoke about. Great. And then we will go one step forward, assuming the demo environment cooperates. I will try to take a query and put it on the IoT Edge so that if the temperature is going beyond a particular point, we can send a command back to the device and ask it to reset itself. Okay? So that's sort of the first part of the demo. We will understand what is the telemetry from the device coming into the cloud by a simple hookup to the Azure IoT Edge, showing it on a Power BI dashboard. The second part of the demo, let's try to deploy an ASA job very easily. You will see the ease of use there onto the IoT Edge runtime so that we command and control the device when it is going out of tolerance. All right, so as you can see, I have a simple Windows PowerShell happening, and from the sensor, I'm generating machine temperature and pressure, and I'm also looking at ambient temperature, humidity, and I have time created. I have a simple ASA job here. This is a Stream Analytics job. Let's look at the input, output, and the query. Input, it is an IoT Hub input. This streaming telemetry from my laptop is directly going into the cloud, into an IoT Hub, where we are pulling the data into Stream Analytics. My output is a Power BI dashboard, and I'm writing to a streaming data set called job1 raw data. Now, let me open my Power BI dashboard, and this is a clean slate. Let me add a tile. Like I said, we support streaming data APIs in Power BI. I select custom streaming data, the data set that I had just pointed to. It is the job1 raw data, and it gives me a few visualization options. I want to create a line chart, time as the x-axis, and values, temperature as the y-axis. So as you can see, there is a little bit of spikiness in the data that is coming from our sensor. Sorry, I'm not able to control this very well. So this is our current data that is coming from IoT Hub. This is pure unfiltered data coming from IoT Hub into my Power BI. Let me quickly show you the query that I had to write in order to get this operational. We looked at inputs and outputs. I think it's time we look at the query. It is as simple as this, a few lines of query. I'm selecting machine.temperature, I'm selecting pressure, and I'm selecting timestamp from IoT Hub that my sensor is sending, and I'm pushing it out into Power BI. PBI out is nothing but an alias for the Power BI environment that I'm sending in. And temperature is the name of the IoT Hub incoming data payload or data stream. With just these few lines of query, I'm able to power this real-time dynamic dashboarding experience in Power BI. So what I want to do next is go one level deeper. I will show you a job that can actually use the real-time anomaly detection algorithms that I said are baked into ASA now, and let's see if we can detect these anomalies. So I have a job here. Let me quickly go through the query to show how easy it is to actually write an anomaly detection query. Okay. All I'm doing here, defining anomaly detection step as I'm getting time, I'm getting temperature, and this is the most important part. The whole concept of writing your own machine learning model and training it is now abstracted out to this single function call. I'm using a function for spike and dip detection, and I want an 80% confidence interval. As long as my model is 80% confident that it could be an anomaly, I want to flag it as an anomaly. It is a completely user-defined parameter. And the other 80 suggests that I want this model, which is pre-trained, to learn from the past 80 events before it starts scoring. And I'm defining my window size as 30 seconds. Stream analytics happens over temporal windows, so I'm defining the temporal window as 30 seconds in this case. And you could, of course, set it to whatever time you want. And my output is I'm sending time out, I'm sending temperature out, and the result of this anomaly detection model is two parameters that are sent out. One is anomaly, which is a binary number, 0 or 1. 1 means it is an anomaly, 0 means there is no anomaly being seen. And these data streams are continuously being sent out wherever you want this information to be written. And the score, the model computes score for every event that is passing through it, so you can get to see the score and if it is an anomaly or not. I hope that makes sense. So let's go to our Power BI dashboard and look if we are able to detect anomalies in this spiky data. Let me go ahead and delete this. I'm writing the output of this job to a new data set in Power BI, custom streaming data set, and it is Ignite anomaly detection data set. I want to use a line chart. First, I want to show the raw temperature along the time axis. Value, temperature. I'm showing 1 minute worth of data. You can set it to 5 minutes up to 1 hour. Apply. So we have just the temperature, the raw temperature. But now, let's make it more interesting. Let's also look at the score and if an anomaly is detected based on the score. Again, the same data set. I want a line chart, time, score, apply. All right, so you can see that whenever there is a spike in the data, our score actually drops down. Just to give you a little bit of what is happening behind the scenes is we are looking at if the model sees any drop or any change in the distribution of the incoming data. So if it is seeing a change in the distribution of the incoming data, it actually drops the score that it is computing. And now, finally, for the most interesting part, which is being able to flag an anomaly. Again, let's use a line chart, axis, time, value if it is an anomaly or not. And I apply. Let me just resize it so that all of them appear along the same time scale. There you go. The moment there is a spike that is detected in your data, the score of the model is dropped and it is being flagged as an anomaly. You can think about all the interesting things that you can do downstream, like you can make a call to Azure Functions, and you can automatically go and reset the machine, or create a service ticket, or generate a text alert. You can send an email. So the options are quite a few once you detect anomaly. Detecting an anomaly is the hard work that you have to do, which is now very simple, but then you can do a lot of other things downstream. So that was part one of the demo. Now, what I want to do is I want to change the distribution of the data that is coming from the IoT sensor by sending a quick command from IoT Hub. I want to deploy new code to the sensor, which is running a custom module. And then I want to essentially deploy an Azure Stream Analytics job on the same sensor. It doesn't exist right now, so that the sensor gets reset when the temperature is above a particular point. Let's try to do that. So right now, the data that is coming from my sensor is spiky. I want to change how the sensor is behaving. So in order to do that, this is my IoT Hub on Azure portal. I click on IoT Edge. My device is called Edge Device 2. Let me look at the modules that are running there. I just have a sensor that is in my IoT Edge runtime that is being controlled by IoT Hub. I click on Sensor 2, and I want to change the data in Sensor 2 to have a uniform data coming in. So just cheating a little bit here. So what is happening here is I'm changing for every event. Percentage change in the data is just 1%, and 500 milliseconds is the duration between different events. So per second, I have 2 events coming in. There is no spikiness in the data, and I'm starting with a value of 10. So I go ahead, I save it, and then I go through a few steps. And here I'm setting the routes for my IoT Edge. So let me talk about this for a little bit because we have time. So first part of the route, I'm sending data from the sensor that is on my machine over to IoT Hub. That's what $upstream means. In the second part of my route, what I'm doing is I'm sending the telemetry from sensor to another job that is actually pulling it into the cloud. And here, once I have my job that is deployed on the sensor, I will send the data from that job into IoT Hub as well. So these are various different permutations and combinations that are set in terms of how to handle the data and telemetry that is being produced on the edge device to be routed onto the edge or even into the cloud. That essentially is what is happening here. So I set the module. And let us see if the sensor was able to get updated. If it did get updated, very soon you will see this Power BI react to it. So the sensor did not get updated, so let me do one thing very quick. Let me restart just the sensor on the runtime. Sorry. Oh. So I just restarted the sensor so that it can get updated better. Okay, so my sensor got updated, and as you can see, it is constantly increasing the temperature value at a uniform rate, and my Power BI has started reacting to it. So what I want to do now is I want to write an ASA job, a stream analytics job, and then deploy that job onto the edge device so that whenever the temperature is above 15, the sensor gets reset to 10 degrees centigrade. All right, so my sensor is behaving, which is good. I have a job here. Let me quickly talk about how this job looks like. Query. I'm getting maximum of temperature and maximum of pressure every 1 second window, right? I'm computing what is the maximum temperature and maximum pressure in that 1 second window. And I'm sending out time, pressure, time created, temperature, pressure, and time created into IoT Hub, which is running on IoT Edge. And this is the most important part. I'm sending a reset command to the device, to the sensor, when the temperature is above 15, right? So this job is not there on my IoT Edge device yet, but it is a very simple query. All it is doing is understanding the maximum of temperature and pressure every second, and if that value computed is above 15 degrees, then it will go ahead and just reset the sensor to 0. Now, I have... That is a system-defined parameter for IoT Hub. So it knows that it is an alert, it needs to do something about it, and what that alert is, it is a reset alert. Yeah, yeah. Cool. I'm glad you asked. So I'm on my IoT Hub. Now let's go and let's deploy the ASA job onto the edge device. That's what I'm going to do now. I click on Set Modules. Right now, I only have one custom module, which is the sensor, custom sensor. I want to add a stream analytics module. So today, you have a machine learning module that you can add, which came recently, a stream analytics module, or a custom module that you have defined. I select stream analytics module, and I can look for all the modules that I have on my subscription, and I know it is the job 3. Save it. It is now publishing this job onto IoT Edge runtime. Let's wait, let's give it a few seconds until it says it successfully published the Edge package onto the device. Now, if I go back to my device, open PowerShell, and look there, I should have this ASA job appear very soon. It's not there yet. Give it a second. It has sensor, edge hub, edge agent. All right. So let's give it some time. Typically, it takes a few seconds even after the portal says that it has deployed the ASA job. But what you see is once the ASA job gets deployed to the sensor, maybe there is some network latency happening here, is that you will see that the sensor gets reset to 10 whenever it goes above a particular point. Let's try one last time. I still don't have it. Let's come back to this once I do my other parts of the demo. Now, what I want to do is I want to show some of these features that we announced today that are more specific to Visual Studio and IoT Edge. One is that let's start with custom deserializers. As you know, a lot of times you have data coming from the sensors that are not just JSON or CSV. The data can be protobuf, or it can be XML data, or it could be any other binary format that your vendor might have sent to you with some libraries attached with it. So let's see how we can start parsing out this new formats of data through custom deserializers. So for that, let me go to Visual Studio. So I have a very simple ASA job here, which is measuring machine pressure from input. But the problem here is that it is a protobuf data. It is not JSON that we can straight away think about and address. And what I have here is a C# implementation of this custom deserializer that I got from my IT team. And as you can see here, under the assemblies, I have google.protobuf already added. If I did not have this, I can go to dependencies, I can manage NuGet code, and I can come here, browse for the right NuGet from the NuGet library, and then install it. For example, if I did not have the protobuf there, I simply search for protobuf, and I can see there is a Google protobuf. I can come here, I can install it if I wanted, but I already have it. So all I need to do right now is go to, let's build this package first. Build. I go to my inputs. My input, as I said, is no longer JSON. It is a custom input. And let me first add a reference. Let me add reference to this C# implementation of the custom deserializer. Let me build it. And now, when I go here, I change this to custom CLR. I see that custom deserializer.dll automatically got picked up. I save this. And when I go to, let me upload new input data, which is in a local file, add local input. Custom deserializer, everything looks good. Browse. Protobuf data, I have it in a local file. I will just use the Visual Studio Runtime IDE in order to do this. And I come here, and I can use the local, I'm using the local input, output to local. Let me run it locally. So job started successfully, and you can see that though it is a protobuf data we could not handle so far, now onwards you can handle protobuf or any other binary format. So that is, and once you are happy with how it is looking, you can just submit it into Azure, right? Your job will get updated whether it is in the cloud, or you can go to IoT Hub and update your ASA job that is running in on the IoT Edge runtime. So that is number one. The second demo that I want to show is the ability to test with live data in Visual Studio. So let me open a new job for that. Start page. I want to use job 1. And mind you, this is a job that is already running in the cloud. The great thing is, even if a job is running, I don't have to stop the job and restart the job. I can use an existing query, existing job that is currently running in the cloud. I can do some tests on it using live data. I was never able to do that before. So all I have to do is I can use the cloud input and output to local. That's all. This is a job that is currently running, like I said, and I click on run locally. Let's see what happens. Text connection to IoT Hub is successful, and the job was started successfully. When I come here, as you can see, the output has started flowing, right? This is the live data. I did not have to sample the data. I'm testing my query using live data. Let's say I wanted to make some changes to the query and understand how the query gets impacted, the results get impacted. I can do all of this here. Whatever I'm doing here does not reflect on the cloud until I come and submit that to Azure. And we show about 500 results, 500 rows right here in the results tab. And we keep writing to a local folder until you terminate the process. Okay? So I have one more thing to show. Before that, let's see if our Edge job ever got updated. Oh, really? Ah, you're right. Thank you. You're right, you're right. All right, now I like when there are smart people in the audience. There we go. We now have the ASA job running on the edge. And if we look at the logs, there is a resetting of the temperature sensor whenever the temperature is going above. You can also see that very easily on the Power BI dashboard, if it ever gets updated. So it was 100, which was, of course, greater than 15. It got reset to 15. All right. So it takes a little while for the calibration to catch up. Yes. It works on both Linux or Windows. The one that I'm using right now is a Linux Docker container on my Windows laptop. Okay, maybe I set it to 10. That's why it's getting reset at 10, but you get the idea. The final thing that I want to show is custom code, support C# extensibility on Azure IoT Edge. So for that, let me open another job, go to the start page, and the job that I want to use is my Edge job to do that. So what is happening here is that I have a simple C# utility that I can call as a UDF that changes any time that is coming from the device. I may have devices spread across all the different regions that are sending payload of the timestamp related to that region, but maybe I want to look at everything in Eastern time zone. So that's what I have. I have a UDF that I have written, a very simple UDF for the demo purposes that changes the timestamp coming from the data payload into Eastern time and then shows everything across all the devices that I have across these different time zones in Eastern time zone. So that's what I have. So what I will do here is I click on the job. This is the ASA job. As you can see, we have now ability to add C# code behind. I add C#. And I'm not a C# developer, but I have a C# code that my developer gave me that I can literally use. And this can be very much something that can be happening in your organization as well. If you want to run a complex math function, chances are a developer probably is not a mathematician. You can use a C# library that was developed by the mathematician in the company, and you can simply plug this into the Stream Analytics extension. Okay, so I have my C# job. Let me go ahead and save it. It's saved. Now I have a local input that I have added. Let me build the job, go back to my original job, and then make a call to this UDF. UDF dot, it is picking up the C# function that I have just written, and then I'm passing that as the parameter because this is what I want to convert to the Eastern time zone. So it's all looking good. I have the sample input that I have already uploaded, and this has local time zones. And let us run it locally for the purposes of this demo. So it will go through its steps, and the job has started successfully. Very cool. So we have the output that I'm just capturing internally, and all the time zones across all my geographies are now converted to Eastern time zone, and now I can use this as an output to power my Power BI dashboards or whatever. So that's all we had to talk about and share today. And if you have any questions, we are going to be here for until the last question. I have some really smart people from our team who helped me put together all these demos and everything. I have Sid and Kathleen as well. They can join me, and we'll be more than happy to take your questions. Thank you very much.